Zeal Education Society, redefining excellence.
Hello, good morning to everyone. Myself, Dr. Mahadev Unde, Professor in Electrical Engineering, Zeal College of Engineering and Research, Pune. In a previous video lecture, we have learned the MMF method of finding the voltage regulation of alternator. In today's video lecture, we are going to solve one numerical based on MMF method of finding the voltage regulation of the alternator. Let us have the numerical. This numerical has been asked in SPPU examination November 13. I will read the question. A three-phase star-connected alternator is operated for open circuit and short circuit test. The ratings are 1000 kVA, 2000 volt, 50 Hz with armature resistance per phase is 0.3 ohm. Determine the voltage regulation of the alternator at 0.8 lagging power factor, 0.8 leading power factor and unity power factor. The observation tables is. Now see the field current in ampere, then the open circuit voltage, line to line values, then the short circuit current. Obviously as it is a star connected, it is the line value is equal to phase value. And the last row is the open circuit voltage per phase, means divide the second row by root 3, so that you will get this one. Now here it is observed that the rating of the alternator is 2000 volt and 30 ampere is required. 30 ampere is required for the generation of the rated voltage, and we have to find out the full load current, and later on we will decide. Okay, the solution. The per phase voltages are calculated and tabulated in the last row as shown in the figure. Now from this available data, we have to plot the OCC and SCC. Take the proper scale and draw the graph. Now see here, everything is taken over here, the observations. Now here the field current, then the open circuit voltage per phase, then the open circuit voltage, line voltage, then the short circuit current. We have to choose the proper scale. Now see the open circuit voltages per phase are ranging from 462 to here it is 1501. So the scale considered, it lies on the y-axis, and therefore y-axis scale is 1 centimeter equal to 125 volt. And on the x-axis there is a field current, and therefore the x-axis 1 centimeter equal to 5 ampere. Here it is some mistake is here, y-axis is by mistake it is written. Okay, so here it is, this is wrong. Okay, now let us plot see the field current, and the scale is 1 centimeter equal to 5 ampere. So this is 5 ampere, 10 ampere, 15, 20, etc. We have written x-axis field current. Okay, and on y-axis 1 centimeter equal to 125. I have marked after every 2 centimeters, say 250, 500, 750, 1000, and 250, 1500, etc. Okay, and on the y-axis it is written open circuit voltage per phase. Similarly, on this y-axis, on the right hand side used for the short circuit test, the current scale considered is, see, y-axis 1 centimeter equal to 50 ampere for the short circuit test. Okay, so here it is, the short circuit test. It is also marked after every 2 centimeter. Okay, so it is 50, 100, and then 200, 300, etc. Okay. Now let us find out. So the OCC has been plotted, and which is shown like this. So this is OCC. Okay, so the OCC is shown here. See, this is OCC, and the short circuit characteristic is a straight line passing through the origin. Okay. Now turn to the numerical. So as the armature resistance Ra is given, you have to follow this formula: V dash equal to Vph plus IRA cos phi. Now what is Vph? Vph is 2000 divided by root 3, as the alternator is star connected, and the answer is 1500 and 1154.7. So the phasor diagram is as shown in the figure. Here it is. See, the Vph, OA is the Vph, then the current is drawn by lagging the voltage by an angle phi, then the IARA, see here, see IARA drawn parallel to the current phasor, then draw the vertical from BD. We have to measure the AD, and this AD is nothing but see, cos phi equal to, just pay attention, cos phi equal to AD upon IARA, and therefore AD equal to IARA cos phi, and therefore the formula becomes, is V dash equal to Vph plus IARA cos phi. Now what is the IA? Vph is 1154.7 volt, and the IA equal to kVA into 10 raised to 3 divided by root 3 into VL, 1000 into 10 raised to 3 divided by root 3 into 2000. The current is, full load current is 288.675 ampere. Okay, so in this way we can proceed further. See the step 1, to find IF1. What is the field current? IF1, that is nothing but a field current required to generate the rated open circuit voltage per phase. Rated open circuit voltage per phase, that is 1154.7, or if the armature resistance is given, then we have to find out V dash equal to Vph plus IRA cos phi. So accordingly, now here the power factor is 0.8 lagging, and therefore V dash equal to Vph IRA cos phi. So it is found that the answer is 1224 volt. Now from OCC curve, find the field current IF1 correspond to this generated voltage, that is 1224. Now let us turn to the graph. See how much field current is required to generate the voltage equal to, see, 1224. It is shown here 1224, and it is observed here that it is, see here, and this is, see here, 5, 10, 20, 25, 30, and this is 33. Here it is 35. Here it is 35. So here it is 33. Okay. So you have to turn to the. So in this way, IF1 is 33. IF1 is 33. Okay. Now to find the IF2, field current required to circulate the short circuit current equal to the full load current, and the full load current just now we have calculated. The full load current equal to short circuit current equal to 288.675 ampere, and therefore from the short circuit characteristics find out the field current correspond to this 288.75, and it is found that the answer is IF2 is 29 ampere. Let us check it. Now see, correspond to IS equal to IFL equal to 288.67. 288.67, see here, 288.67. From this, the current required is 29 ampere. It is 29 ampere. See, it is shown here. Just check it. Correspond to 288.67. The field current required is 29 ampere. So IF2 is 29 ampere. Okay. So in this way, we have obtained IF1 and IF2. Then we have to find out the resultant of this IF1 and IF2. Okay, let us proceed for finding the resultant. Okay. So step 3 is to find the resultant field current IF. That the power factor given is 0.8, Therefore, phi equal to 36.87, and therefore, see, let us draw the phasor diagram for a leading power factor. See, OA is equal to IF1 and IF1 is 33. Draw as a reference. Then draw a dotted vertical line. Draw the dotted vertical line from point A. Now draw the AB equal to IF2. See, AB equal to IF2, that is equal to 29 ampere, lagging the vertical line by an angle phi. Okay, then join OB. OB represent the IF, feed current, that is the resultant feed current, and it is found that it is 55.48. Now how it is obtained? See this formula. The IF equal to square of the two sides of the triangle, known sides of the triangle. That is IF1 and IF2 are known to you. So IF1 square plus IF2 square minus 2 times IF1 IF2 into cosine of angle between them. Cosine of angle between them is 90 plus phi. And therefore, when you obtain, take the square root of this, answer is 55.48, and correspond to this field current. Step 4 is correspond to this field current. Let us find out the no load voltage generated. That is the no load voltage from the OCC. Now let us turn to the graph. We will find from the graph the feed current is 55.48. See, it is shown here. The feed current is 55.48, and correspond to this, how much is the now pay attention. If you observe carefully, this is IF equal to 55.48, and correspond to this one, let us locate on OCC, and the answer is somewhat 1575 volt. 1575 volt. This is the answer. 1575 volt. Okay. So once you have obtained from the step 4, we have to find out the voltage regulation. So see, the correspond to this field current IF equal to 55.48 ampere, the generated voltage, no load generated voltage from OCC is EF equal to E0 equal to EPH, and that is equal to 1575. Just now we have calculated. Then step 5 to find the voltage regulation. The percentage voltage regulation is EPH minus VPH upon VPH into 100. Therefore 1575 minus 1154.7 divided by 1154.7 into 100, that is 36.4. This is the answer for the voltage regulation of alternator at a lagging power factor using the MMF method. Similarly, we have to find out the voltage regulation at a leading power factor and unity power factor. Now let us observe for this one. Now see, at a leading power factor of 0.8. Now see here, pay attention here, the IF1, IF2 will remain same, and IA, that is the armature, full load armature current equal to short circuit current, that will also remain same. Only we have to find out the resultant of this. Now how to plot the graph of this? Pay attention here. Take the horizontal OA as a IF1 is 33 ampere, draw it as a reference. From point A, draw a dotted line, vertical dotted line as shown. Then draw the AB, that is IF2, leading the vertical line by an angle phi. And therefore, the join OB represent the resultant of this feed current, and it is found that it is equal to 27.96. And what is the angle between the IF1 and IF2? That is 90 minus phi, because this total angle is 90 and this phi is subtracted from this. So 90 minus phi is 53.13 degree. So using this, for the triangle, two sides are known. The third side is the square root of the IF1 square plus IF2 square minus twice IF1 IF2 into cosine of angle between IF1 and IF2. Take the square root. So it is found that the answer is 27.96 ampere, and correspond to this feed current. See, this is the resultant feed current, and correspond to this resultant feed current, we have to find out the no load EMF generated from the OCC we have to observe the OCC, and it is found that the answer is 1075. Let us check it on the graph. Okay, so correspond to see, this is a 55 point, just minute, what of the resultant? 27 point something. See, here it is a 25, here it is a 30, and 27.5 is somewhere, it lies here, 27. So if you look here, this is the 27, and corresponding it is somewhere here, and the value is 1075 volt, 1075 volt. Okay, so from this you can obtain the voltage regulation. You can obtain the voltage regulation. You can obtain the voltage regulation. Now, to find the voltage regulation, percentage voltage regulation, that is the step 5. EPH, no load voltage minus full load voltage, or rated voltage divided by full load voltage into 100. So 1075 minus 1154.7 divided by 1157.4 into 100. It is found that the answer is, at the numerator, the E0, EPH is less than VPH, and therefore the voltage regulation is negative. So the voltage regulation is negative for a leading power factor. Now let us see the unity power factor. For the unity power factor, cos phi is 1, and therefore we have to find out this V dash, and V dash is VPH plus IRA cos phi. And it is observed that the V dash is 1241.3. So it is close to 1250. Close to 1250. We will check on the OCC. You have to find out from this open circuit voltage, you have to find out the IF1 correspond to this value. Okay, here we have to find out IF1 correspond to 1241 from the OCC. Okay, and it is found that it is 34 ampere. Let us check it. So correspond to 1000 and how much it was? 24 or 42. Just check it. So 1241, the answer is 34. See, the 34 is shown here. This is 30, this is 33, and 30. Here it is 35. Here it is 35. Here it is 33, and it is somewhere here. So it is 34 ampere. It is not shown, but it is 34 ampere. It is here it is 33. Here it will be 34. 34 correspond to, here it is 1000. Here it is 1250, and it is very close to 1250. It's 1242. So it would be around 33 or 34. Let us check it. So it is the 34 ampere. Okay. Now IF2 will remain same. IF2 will remain same, and therefore for a unity power factor, draw OA. Then draw the perpendicular line AB as a perpendicular, that is IF2. Join the OB. Use the simple Pythagoras theorem, or otherwise use the Pythagoras theorem, or otherwise use the same formula. IF1 square 34 square plus 29 square minus 2 times 34 into 29 into cosine of angle between them. So the cos 90 is 0. So obviously you have to use take the square root of, that is the Pythagoras theorem. Say answer is 44.69 ampere. Now we have to find out, correspond to this feed current, how much is the no load voltage from the OCC, and it is found that the no load voltage is 1424 volt from OCC. We will check it. See, the correspond to 44.7. See here 40, here it is 40, here will be 45, here will be 50. So it is a slightly less than the 45, say 1 mm less. So the corresponding figure is, pay attention, here it is. This is the point. And from this, here it is a 44.7. So correspond to 44.7, the no load voltage is 1225, and therefore the voltage regulation at a unity power factor is, see, 1425 minus 1154.7 divided by 1154.7 into 100. That is no load voltage minus full load voltage, or rated voltage divided by rated voltage into 100, and the answer is 23.41%. So in all, at a point rate lagging power factor, for a power factor at a lagging power factor and unity power factor is positive, because EPH is greater than VPH. Okay, but however, the voltage regulation at a lagging power factor is greater than the unity power factor, and voltage regulation at a leading power factor is negative. And also remember that voltage regulation is 0 is possible at a leading power factor. So in this way we have finished this example. I hope there would be no any difficulty. You can refer it neatly. We will stop here. Thank you very much.